In this video, we are going to talk about Kirchhoff's voltage law, or KVL. But before that, let's remember that what is voltage? Well, voltage is a measure of energy associated with charge flow across two nodes in a circuit. So we already know this concept very clearly, okay? So now let's look at what is KVL, or Kirchhoff's voltage law. So let's draw a diagram, something like this. And let's say this is point A, this is point B, C, D, and E, okay? And we are moving in this direction that is shown here. So our path in this direction. And the KVL states that potential difference between point A and B, or VAB, plus BC, VBC, plus VCD, plus VDE, plus VEA will always be equal to 0. So we are moving and completing one loop, and we are returning to the same position, point A, okay? So this is the KVL, and this is Kirchhoff's voltage law in a simple way. So actually, this relation says that this is nothing but equal to VAA, right? And what is VAA? VAA is VA minus VA, so it will be equal to 0. We can also show like this. This B and B will cancel each other. This C and C will cancel each other. D and D cancel, and E and E also cancel each other. So we would have VAA equal to 0, right? So let's go to another example and see what we exactly mean by this. So let's draw a circuit, simple circuit like this, with some components in it. We have 2 and 3 terminal components, and let's say this is V1 plus minus, this is V2 plus minus, V3 plus minus, and V4 plus minus. Okay, what do we mean by plus minus? Well, plus side will have high potential and minus side will have low potential. Okay, now if we want to go from point A and return and go one loop, okay, and complete this loop and return to the same position, point A, we'll have this relation. KVL says that we should have like this. Okay, so since we're going from high potential to the low potential, we can say that it will be minus V1, since we're going for this direction, right? From high to low. So it will be minus V1. And we can go from, again, high to low. So it will be minus V2. Again, for V3, we can say that from low to high. This time, from low to high, it will be plus V3. And then from low to high in V4, it will be again plus V4 equal to 0. So we are reaching to the same point, right? And someone can say that, okay, I don't want like this, I want to v1v. So we can also multiply this, we can write like this, v1 plus v2 minus v3 minus v4. It doesn't matter, right? So we can write in this way as well by multiplying the equation to -1. Okay, and this is the relationship that we're getting. And another interesting fact that's it's worth to mention is that, let's say, let me clear this parts, okay, and let's say we have point B here, okay, and we are asked to find the potential difference between point A and B, or specifically, what is VAB? What is VAB? So VAB, we know that it will be VA minus VB, right? And we are moving, let me write it in with green, we're moving from A to B. So it will be, since we are starting from in point A, so we will have VA, the potential difference. Let me write in this way, okay. The potential difference A. Then from high potential to low potential, so we would have minus V1, because we are going from plus to minus, we will have minus V1. Then the same for the V2, from high potential to low potential, it will be minus V2, equal to VB, the potential in the point B. So then we can say that VA minus VB will equal to V1 plus V2. So we found it, okay? We found the relationship here, right? Okay. So here we have some conditions that we can see. We have some resistors and batteries, LTI resistors. So we know that in the wires, the electrons are moving due to the electric field that is existing in the wires, right? So, for example, in two parallel conductor, we can say that, for example, this is positive side, then this is a negative side, right? And the electric field lines will be like this. And the electric field lines will be always from positive to the negative side. So if we put an electric charge, positive electric charge, it will be repelled from the positive plate and it will be go to the negative plate, right? So we know this. And current will always be in the direction of the electric field lines. Okay, so we already know this. And okay, by knowing these parts, then let's say for the case number 1. So if in the loop, or that the path we're taking be in this direction, okay, this is our direction of move, then we know that, we already know that current will always flow from the high potential or plus to the low potential, right, minus. So then since we're going from high to low, then the potential will be minus IR. Okay. We also know that because of the Ohm's law, this equation is true, right? Okay. And if we move the opposite direction, then we also know that the current move from positive to the negative, from high potential to low potential. But our path is from low potential to high potential. So since we are going from low to high, it will be plus IR, right? And in the battery, let's say our direction is in this direction. Since we're going from here is high, right? Because it is positive, high potential, and here is low. So we're going from high to low. So it will be minus V. And if we move from this direction, in this direction, then it will have from low, we're moving from low to high, right? Our path. So it will be plus V. So this is true, right? This is simple and true. Okay. But how can this be? For example, in case number 4, we said that the current is always going from positive. So this is, let's say this is current, always from positive to the negative, right? But in case 4, the current is from, battery is it is exactly the opposite. Maybe this is just a part of a circuit. We don't know. Maybe there is some batteries like this. This battery number 2, okay, might be very stronger than battery number 1. So the overall current will be in this direction, and it will be in the clockwise direction, right? So let's consider this, and let's go to the other part and see some examples and learn about them. Okay, let's look at this simple example to be clear about the concept more, the concept of KVL. So here we have a circuit, and we have some LTR resistors and batteries, and X is the potential difference across the battery that is shown. And what is it? What is X? And also the potential difference between points A and B. So for the first one, the solution that we have, the relationships that we have learned so far, is that we can start from point A and go like this. We have a loop, right? So whenever we are moving in this direction, so we know that this is positive, this is negative side of the battery. And so remember that we said that we are going from the low potential to the high potential, right? So we will add this. So it will be plus 5 volts, right? And we said that the current will always be from high potential to the low potential. So since we're going from high to the low, it will be minus IR1, right? And then we are going and reach to this battery, okay? So from high, the current is going from the high to low, right? So it will be minus X. And then in this resistor R2, we're going from high to low, right? So it will be minus IR2. So this whole equation will be equal to 0, okay? And so we need to just substitute some numbers. 5 volts minus I is 2, R1 is 3 ohms, minus X minus 2, 8 equal to 0. So we will have 5 minus 6 minus 16 equal to X if we move X to the other side. So this will be minus 1 and this will be minus 17. So X will be minus 17 volts, right? So for the next part, the second part of the question, number 2, we were asked to find VAB, the potential difference between point A and B, from A to B, okay? So we know that VAB is equal to VA minus VB, right? So we can start from point A and go all the way to point B, like this, okay? It is like semi-loop, right? It is not a loop, but it's semi-loop, okay? So here we can say that we are starting from point A, so we will have potential in the point A. Then on our path, we will reach to the battery, this battery, right? So in this battery, again, as we saw before, we will have plus 5 volts because we are moving from the low potential to the high potential. And then we will reach to the R1 resistor. And we will move from the high potential to the low potential. So as a result, we will have minus I R1. And then we will reach to point B. It will be equal to potential in the point B. So if we substitute, we will have VA plus 5 volts minus I. What is I? It is 2 times R1 is 3 ohms. It will be equal to VB. So if we solve this, VA minus VB will be equal to, this is 1 volts, right? So we solve the second part of the question as well. So that's it. That we have learned the concept of KVL, and I hope this video was useful, and thanks for watching.